now we will see the experiment, right. So, if you recall, so we have applied a system input at this point. So, if you recall the explanation on the board, we are using a pot as a system input, and the sensitivity that we have selected, that is nothing but our the factor at which the input the relation between the input voltage and the temperature is somewhere around 1 volt per 10 degree centigrade. So, which means that 0.1 volt per degree centigrade. So, that means if I apply 5 volts as an input to the system, so that is corresponds to 50 degree centigrade. Okay. So, what we will do now is that we will apply 5 volts using potentiometer at this point, and as we have already seen, we have constructed a signal conditioning circuit for the sensor, and the sensor was stick on to the plant. The plant in this case is a transistor. On top of a transistor, we stick that temperature sensor. The temperature sensor that we are using is LM35, isn't it? So, since the factor was different, the input factor and the output factor of sensor output is different, we are using a signal conditioning circuit, and that signal conditioning circuit we have connected externally. So, the output of this is again connected to the board. So, at this particular point it will be connected. So, depends upon what type of a controller that we are using, whether PI or on off controller, the working of the complete system will change. So, if we look into the circuit board here, so this is the pot. When we look into the board, so this is a pot. So, this pot, by varying the knob, we can see what input voltage that we are applying, which means that the corresponding set temperature value, and this is our transistor. On top of it, there is a LM35 sensor. So, this particular breadboard is a signal conditioning circuit for the sensor, and the output is connected to the sensor point. So, right now, when you observe on the multimeter, when we see the complete multimeter, right now it is showing as the input voltage. This multimeter is connected to the output of the pot, which means that the input we have connected to 2.2 volts, meaning I am asking the temperature to be maintained on the plant to be of 22 degree centigrade. Now, is it possible to maintain 22 degree centigrade? Right now, if I see, we do not have any other air controlling system or cooling system in our place. So, that is the reason beyond our room temperature it cannot go below. If we have external AC or some other cooling system which can accordingly change the temperature value, even the output can maintain as 22 degree centigrade. So, since we can only heat in this case, what I am doing is I am putting the temperature to be 5 volts. So, which means that I am expecting the temperature on top of the transistor to be of 5 volts. So, what I did, I am changing to 5 volts, right. So, this is right now at 5 volts. Now, this is set point. So, what is the actual temperature on the sensor? If you want to see the actual temperature on the sensor, when we look into the CRO, here we can see. So, the right now temperature is 0.51, see here, it is slowly increasing, right, and this particular line, this line is 5 volts, because the one particular margin, the one block is corresponds to the 5 volts that we have set here. The channel, if I see, the blue one is 5 volts, and the yellow color is nothing but output from the controller. So, the board is right now connected to on off controller, right. So, that means that the output of the error is connected to the controller input, and the output of the controller is again connected to this controller, in the sense on off controller is connected to the heating circuit. So, if we recall what we have discussed in our on off controller and the simulation, we have seen that when the input voltage or when our temperature value, if you recall what we have seen, right. So, if the input signal is greater than one particular threshold, the state will change and it will keep on fluctuate, right. That we have already observed even in our simulation too, right, by using multisim. Now, even if you observe that the set point here that we set was, as we have calculated in our theory session, right, by using those resistors, by using those pots, we have considered few set points. And now, since the input temperature is of 50 degrees centigrade, that means the 5 volts we have applied as an input system, whenever the temperature is greater than 50 degree and that is higher threshold value, it is making the on off controller to go to the off state, we can see clearly, right. And when the temperature is below the second set point, somewhere it is very close to 50 degrees centigrade, in this case 5 volts. If I want to talk with respect to the voltages, below below 5 volts, somewhere around 4.9 some value, whatever the resistor that we have choose based upon that, again the on off controller is switching on. That means it is allowing the transistor to start heating it. So that means it is clearly seen that the on off controller is keep on switching on and off of my plant. So, based upon on and off, how much time it is on and how much time it is off, and depends upon the convention, external parameters, the switching on and off everything will depends, right. So, as a result it is trying to maintain the temperature on the plant to be around 50 degrees. It is not very close to 50 degrees, around 50 degrees. That around entirely depends upon what is the gains, what is the thresholds that we have set on off controller and external parameters too, right. So, right now it is at 50, why do not we change it to some other value, right. So, when we look into multimeter, right now it is at 5 volts, what I will do is that I will change to somewhere around 60 degree, meaning 6 volts. Now, see whether it will be switching on or off, how exactly it is. So, what I will do is that I will slowly increase the pot. So, right now it is in off condition and I am asking to be at 60, so that is why it is switching on. Right, I have set it to 60. So, till it goes to 60, it is updating, the CRO is updating. So, we can see here. So, it has reached to somewhere around 60, that is why the on off controller is off, and again when the value is slightly higher than. So, what I can do is that to make it visible, I will increase the time division to 2 volts. So, previously not time division, I mean the amplitude division. Right now previously it was at somewhere around 5 volts one block, right now one block is 2 volts. Here we can observe here 2 volts. So, here we can clearly see, and since the value is 6, so 2, 4, 6, the third line, here we can see this particular third line is 6 volts, right. So, when we see the output is slowly increasing and decreasing. So, whenever it is increased more than 60, that means this particular dotted line, we can see switching off the on off controller. When it is below that particular dotted line, it is again starting it, we can clearly see that. So, that means one thing is clear, that the on off controller is not maintaining exactly at the 50 degrees or exactly at the set point. That is what even we have seen even in our theoretical. So, as long as if your plant can withstand for onning off, on, off and on, there will not be any problem, and it is very easy to implement too. Now, we can also see, so we have observed with the changing higher value. So, suppose See, right now the temperature is at somewhere around 60 degrees centigrade. So, if I want to understand, if I put any thermometer, so right now LM35 sensor is also temperature sensor, or we can even experience the heat by touching the transistor too. So, right now it is a 60. What if I suddenly change the input voltage to 10 degree? So, since it is a 60, whereas the set point what I am decreasing it to 10 degree, then we can see on off controller should be off for certain duration. That duration entirely depends upon the convection too, till it reaches to 10 degree, right. Since we do not have an external cooling system available here, we cannot see the on off controller in on condition at all. So, what I will do is that I will make it as 10 degree when I look into the multimeter. So, when we look into the multimeter, when I look into the multimeter, I am changing, I am decreasing the voltage value. So, decreasing value to somewhere around 1 volt. So, 1 volt meaning I am expecting the temperature on top of the transistor to be 10 degree, right. 1 volt meaning 10 degree. So, if I observe now, due to external convection, the temperature on the transistor, it starts slowly decreasing. It started slowly decreasing, and since we do not powering it on, the reason is that the error value, the threshold value is higher than the temperature value, because the set point value is very smaller in this case, and the temperature on top of the transistor is very higher. That is the reason the on off controller is still in a switch off condition. We can observe that on off controller simply in switch off condition. So, due to external convection, so in order to heat it very fast, in order to cool it very fast, what we can also do is that we can blow some air. So, we can see some sudden drop in temperature value, because we are externally convecting, we are externally blowing some air, so that heat will be convected. Slowly cools down, and even we can touch on top of the transistor, so that it conducts. So, no matter whatever may be the possibilities, it has to maintain. So, let me change it to somewhere around 30 degree. So, 30 degrees more than room temperature value. So, whenever the temperature value is greater than 30 degree, it will switch off, and if it is lower than the 30 degree, again it will switch on, right, somewhere around 31 degree we can see. So, right now the temperature value is somewhere around 244.5, that means 45 degree, still it is cooling down. So, I am externally blowing air. So, it started cooling. So, if I want to switch it on, the temperature value should be below 31 degree centigrade. So, that means that, so somewhere around this point, somewhere in between these two boxes, if this value is between these two boxes, that is 3. So, why it is taking time? Because it has to naturally cool it down. So, since it is taking too much of time, what I will do is that I will keep it as 35. So, 3.5 value. So right now it is at somewhere around 38. Since the thermal gradient is very smaller, it takes too much of time to cool it down to. Now we can see the temperature value has become lower than the 35 set point, then the controller started switching on. So since it switched on for particular duration, that it has powered the system, and how much amount of energy is given to the system entirely depends upon what is the gain that we have set. So since it was powered for small duration, that was enough to heat it to such a higher value. So that is why it will be off for a particular duration. It will be off for longer duration because the thermal gradient at this stage is very smaller. So depends upon what is the set point that we are using, depends upon what is the gain that we have set on off controller, the complete pulse like complete frequency of the pulse entirely depends upon those parameters in this case. So basically it depends upon the thresholds that we set for on off controllers. So right now the temperature is somewhere around 36, 37, 38. I will simply blow some air. Right. So because of that the temperature has become lower. Again the on off controller started. The yellow color line we can see, that is an output from the controller. Right. So this is a way we can easily understand the working of on off controller, how the controller will goes from one state to the another state, depends upon the thresholds that we have set, and depends upon the set point, depends upon the temperature on top of the transistor. Now we will see the demonstration of P controller. So as if you recall our complete circuit board, we made a jumper connections, right? We made a jumper connections, and if you change the input jumper from on off controller, when I look into the circuit board, if you change the jumper connections from on off controller to P controller, right. So simply changing the jumper connections from on off controller to P controller, because we have created one for on off, other one P, other one is PI as well as PID controllers too. So now right now the controller that we are using is P controller. So when I look into the multimeter, the set point that we are using is 3.6 something, right. So what I will do is that so the error value is very smaller. I will change the set point to somewhere around 5 degree, so easy to understand. So sorry, 50 degree, which means that 5 volts. So the right now the temperature is somewhere around 36 something, and the set point is 5 volts, 50 degree. So since there is an error, so if you see the controller output, that is yellow color, the error was too much. Because of the error was too much, it is pumping higher amount of energy. Because of that higher amount of energy, the temperature started increasing. Because of increasing temperature, the error also linearly decreasing. So since the error value is linearly decreasing, the energy that is pumping into the system is also smaller, and because of your natural convection, it is also getting it cooled. So since it is 5 degree, so the value is 2, 1 amplitude is 2, 4, and this is 5. So in order to understand, what I will do is that I will create a cursor. I will create a cursor and keep it at 5 volts. So cursor 2, I will select cursor 2 and I will keep it at 5 volts. right. So, this line, this straight line. So, other than that what I will do is that rather than creating cursor 2, I will go with a cursor 1 which will be yellow in color. Oh sorry, that is also blue. Or I will take source as channel 1 and I will change this to 5 volts. Cursor 1 somewhere around here, right. So, that is the 5 volts, or I will switch off the cursor, that is not a problem. Okay. So, this particular complete line, this is a cursor value. So, since both are in same color, it is difficult to identify. So, that is right now it is at set point somewhere around 5 volts. If you see that, right, the temperature is completely maintaining. Now, if I blow some air externally using some external system or something, so what happens, the temperature will cool down. As a result, the error value will also be little higher. So, because the error is higher, the proportionally the input voltage that is being applied to the plant will also be higher. As a result, the current flowing through the plant will be higher, starts its heating. We can also observe that. So, we can see the temperature, because of blowing air, the temperature is decreased, the error value started increasing it. Since the error value started increasing, as a result, right, the voltage applying to the system is higher. But finally, if you observe, again it starts maintaining to 5 volts. So, the difference between the previous circuit on off controller and the P controller is that the P controller can maintain the temperature, but on off controller it cannot maintain, it will try to settle within the range that we have specified, it will by switching on and off. So, if that particular range is okay, we can either go with a very simple controller, on off controller, or if you have to maintain completely, we have to go with some other controllers like P or PI or PID controllers, right. Also, the rise time of the complete system, the rise time of the system depends upon what is the P gain that we are using. Smaller the gain, higher the smaller the P gain, higher the response time, or I can say it takes longer duration to reach to the set point. If higher the gain, it takes lesser time to reach to the set point. If I want to understand that, what I will do is that I have to increase again, it has to cool down, then it has to I have to start the experiment after cooling down to room temperature, and then we have to see what is the response time, rise time of the system. So, based upon the different gains, we can also identify the corresponding change in the response based upon the change in the P controller gain, right. So, it is, since it is it takes some time, I hope this is okay for us. So, now what I will do is that I will change the temperature to somewhere around 60 degree. So, that means 6 volts apply, right. We can see 6 volts in the sense it has to reach to this particular point, this line, right. So, the temperature started slowly increasing, we can see now it has reached to almost close to 60, somewhere around 59, we can see why this particular controller output has increased and decreased, because since there was some error between the set point and the actual output voltage, because suddenly I have changed the input from 50 degrees to set point value from 50 to 60. As a result, the error change was higher, somewhere around 10 degree, that because of that error, since we have applied some gain, it will be multiplied with the gain factor of that value, right, gain factor into the error value, that corresponding controller output is nothing but this value. This particular voltage will be given as an input to the plant. So, as a result, when the error is too much, very high input was applied to the system, causing the temperature to reach to the set point. As a result, the error value will be will be smaller. So, here we can see the error slowly decreased. So, it happens when the input voltage is reaching to our set point, right. So, no matter what, so one thing it is clear that when we observe our on off controller as well as a P controller can maintain, but on off controller always switches from in order to maintain the temperature, it will always switch on and off. Okay. So, now we will see the working of a PI controller. It is easy to understand about what type of controller that we are using here. So, when it is an on off controller, you can observe the output of on off controller to be a square wave. That is the reason it will always either in positive saturation or negative saturation. But whereas in case of on off P controller, we can see it depends upon the error value, the output of the controller is proportionate to that of your error. So, if the error is higher, the output is higher. If the error is smaller, the output of the proportional controller is smaller. That is why it is called proportional controller, entirely depends upon that error. Now, we will see the working of PI controller. So, this is what the circuit that we have used even in the board. So, what we do is that, so since we have completely designed the board, it is only simply just replacing the wire from P controller to PI controller. So, what I will do is that I will change the input from PI to, that means the error value is connected to PI. So, similarly the output is also connecting it to the PI controller. So, since right now it is at completely at 60 degrees centigrade. So, it is very hard to understand how exactly the PI controller works. What we will do is that we will let it cool it down. So, that is why I am putting the set point to somewhere around 100 milli. When I look into the multimeter, we are setting it to somewhere around 100 milli. Let it cool down, then we will start our experiment again. Now, it has cooled down to since we have kept the set point to somewhere around very low temperature value, somewhere around 101.9 millivolt. So, that means approximately 0 degree centigrade, and since room temperature cannot go beyond certain temperature value, right, because we do not have external cooling system, right. So, the temperature on top of the transistor is also equal to the room temperature at present. Now, in order to understand the demonstration how exactly the PI controller works, what we do is that we will change the set point to somewhere around same 5 volts, which is nothing but 50 degree, and we can observe how exactly the PI controller output is changing, as controller output is changing, as well as the change in the output temperature too. So, just let me refresh the screen, then I am putting the temperature the set point to be 5 degree. When I look into the multimeter, we can understand what temperature value that we are setting it now. So, 4.22 and this is 5 volts, right. Now, we can see depends upon the what is the gain that we have used, right, and depends upon what is the current temperature value. The value started increasing, the error value, right, we can clearly see that. Okay. So, previously it was in negative, this was completely negative, and it started increasing. So, and the what is the rise time, how fast it has to reach to the set point, entirely depends upon what is the gain that we have set. So, if I change the P gain as well as I gain in the PI controller, even the time taken to reach to the set point will be very fast, will be smaller value itself. If the gain is smaller, as a result, since the gain will be smaller, it takes little longer duration in order to reach to the set point. Now this particular line is 5 volts, right, 2, 4, and this is 5 volts right now. So it has almost reached the set point, right. We can see it started, it reaches to set point, and we can also observe what is the controller value. Now the difference between a P controller and PA controller is, here we are adding some intelligence by using integrator. So integrator, when I simply change the temperature value from 50 degree to 40 degree, it will not suddenly change, it is not a proportionate action. So it depends upon cumulative of errors, accumulation of my previous errors, right. If even though if the temperature is, for example, if the error is maintaining at always 10 degree, the error will be keep on in case of, for example, like say the set point is somewhere around 40 degree, as well as the output is somewhere around 30 degree. So if you observe there is an error of 10 degree. If it is a proportional controller, as long as there is a 10 degree error, proportionately the output will always be at the same value, no matter what. But in case of an integrator, it is not like that. Now at this particular time instant, if the error is 10 degree, it will provide some particular output voltage. Now even after some x1 time duration or t1 time duration, if the error remains the same, the input voltage or the output of the controller will not be the same value, it will be higher than the previous value. That depends upon how much duration that error was maintaining at the same value, right, and depends upon what is the gain that we have set. That is why it is like addition of your previous error. It does not depend not only on your present error value, it depends upon your previous errors too. That is why integration is nothing but area under the curve. So at this particular time duration, how much area is under the curve is nothing but your integrator. So that is the reason, even though if the error value is a constant, the output will not, the proportional controller output will never be a constant, it will be keep on increasing or decreasing, depends upon whether you are in a positive error side or a negative error side. Now we can clearly see that no matter what, it depends upon the I gains and P gains that we have set in a P controller, but it has reached to the set point. Now even the same thing what we have observed with a P controller and PA controller, almost the same, it is maintaining constant temperature. But when I compared with the on off controller is not like that. On off controller is completely like on off switching, that means the controller output will be always in a pulsating mode, right. Whereas in case of P controller as well as PA controller, depends upon your set point, right, depends upon the actual temperature value, it automatically changes your controller output. Once it reaches set point, some minimum amount, that means the system is completely on, but the input voltage or input power applied to the system is very smaller amount, right. But the difference between the P controller and PA controller is that the P controller, the major problem with the P controllers is that if we are going with a higher order systems, apart from 0 order system, if we are going with the first order or second order system, basically with second order, even though if we reach to one particular value of control gain of P gain, right, even if we keep on increase the gain of P controller, there will always have an offset. Offset is nothing but the error between your set point to the actual output. Even if you keep on increase P gain, that offset will remains constant, right. So in order to eliminate the effect due to the offset, this generally seen in higher order system, somewhere around first order and second order system basically, and more than first order system. If your system is if you are observing such an offset, even though if you keep on increasing the P gain, if that offset was really negligible change in the offset error, one way to eliminate that offset is by using I controller. So the combination of P and I, what it does is that it not only eliminates the offset created by the P controller or offset that was not eliminated by using a P controller, the time taken to reach to the set point will be really faster. Within less duration it can go to set point, but the problem is that in order to reach to within a less duration, initial the pump in current, in this case the pump in current or the pump in power will be really higher. If your system unable to withstand such a higher power, there are chances of damaging a system too. So, one way to avoid is you have to observe whether whatever the gain that you have set is within the operating range of your plant. If it is not in operating range, that surges or that sudden increase of current completely damages the system. So, but if you require such a faster output, faster setting time, but it is providing you overshoot, one way to eliminate that overshoot is by using addition of a decontroller. So, the combination of P, I and D not only eliminates an offset, it also decreases the overshoot, and it will not have any influence on your rise stem at all, right. So, but what happens, as long as you are adding one more term into the system, the complexity of the system will be little higher, right. So, in this particular case study, we are only seeing about on off P and PI controller. I hope this is clear to you, when to go with the P, when to go with on off, when to go with the PI and when to go with the PID. So, now right now it is at continuously maintaining at 50 degrees centigrade. Now, let me change the temperature value to 50, right, sorry 50, I will change the temperature value to 60 degree. That means, I have to apply input voltage of 6 volts. So, applied input voltage of 6 volts. We can see depends upon the gain that we have set, even though the voltage was the difference was only 10 degree. See the sudden change in the controller gain, right. Now, 60 in the sense this particular dotted line, right. Now, we will see how long it takes to reach to that dotted line entirely depends upon the gains, Kp and Ki gains in this case, right. It is almost reached within less duration itself. Right, reached, that means it is already settled. Now, what I will do is that I will keep it at 30 degree, and let me see whether it is cooling on, and we do not have any external cooling, by the way, naturally it has to cool down. So, if I clearly observe here, since the error is very higher and the error value is negative error, right. If you observe that the output has gone to negative. So, when we recall the plant working, when you apply negative voltage, there will not be any passes of current into the transistor. As a result, it will not heat, because that means the transistor will be completely off state basically, right. So, that is why even though the error is higher, the output of the controller is going to negative value, but it will not have any influence on the plant, because it has to naturally cool down. So, till it reaches to 30 degree, right, it has to naturally cool down. Once it reaches to 30 degree, again it starts maintaining the temperature of 30. So, to understand what I will do, it rather than going with 30, I will go with the 40. So, it takes lesser duration compared to that, 4 volts. So, right now it is at 50 degree. I will blow some air. So, 40 in the sense it has to reach to this particular dotted line, the below dotted line. So, right now it is somewhere around 42. So, it is almost close to 40 degree. Now, if I see, if it would have been a proportional action, it would not have been in a negative direction, it will be in either 0 or in positive, small positive, because it is already close to 40 degrees centigrade. But in this case, this since it is a PI, it not only depends upon the present error, it also depends upon the previous error, right. So, since the error accumulation was too higher because of negative, it was not it is not going to 0 state, 0 voltage at all. So, it takes some duration to go to the proportional controller output to go to the 0 volts, and then slow it is a for proportional integrator slowly to 0 volts, then slightly increase in input voltage, right. So, that entirely depends upon the previous errors too, not only the present error, previous error. It is naturally convecting. Now, it is in, actually speaking, it is in off condition. It is also at 40 degree slightly decreased, the temperature value is slightly decreased, but even then the system was not yet turned on because it is below 0 degree. This is 0 volts, below 0 volts the value is still. Right. If it is a proportional action, right, it should be somewhere around close to higher than the 0 volts. So, the output temperature value is somewhere around 39 degree. So, we can clearly see it is slowly decreasing. So, it started now. So, if I see the controller output, it was somewhere close to 0 volt, increasing. Now, the temperature is 38.5. So, started the temperature controller, if you see the PA controller, it has slightly increased the output voltage of the controller. So, now that means now the temperature it started increasing. So, if you see, since it is not a great amount to start heating it, so even though it is maintaining at 38.5, after some duration you can see the values keep on increasing. So, if you observe from here, there was no from here if you see there was no change, but even then the values started increasing, and it will linearly increase as long as if your error was not changing. That is the beauty of our PA controller in this case. That is because of our accumulation of your previous error. Right now, if you see the current temperature, now it has gone to 40 degree. Now it will be maintained at that particular value. So, I hope this is clear. So, this way we can understand the difference between on off controller, P controller and PA controller, and how when to go with the P controller, when to go with on off controller, and when to go with the PA controller. So, how exactly the controllers works depends upon what type of control action that you are using, how exactly it works, that completely demonstration we have seen now. So, thank you.